Hello, my name is Nick and I hope you're having a great day. In this video I'll be looking at the Dijkstra algorithm. I'll explain the theory behind this algorithm and then implement it using Python. Here's some background info about me. I'm 19 years old and I'm studying a bachelor's in computer science. I'm not an expert in algorithm engineering, so don't expect this video to answer all your questions. This is merely an introduction and I'm certain there are more efficient ways to compute a Dijkstra algorithm. This video's purpose is simplicity, so I'll be missing some technical terminology which will confuse inexperienced users. To add, I'll also post links to my GitHub repository and LinkedIn profile in this video's description. So, what is the Dijkstra's algorithm? Dijkstra's algorithm was conceptualized in 1956 and then published in 1959 by a computer scientist called Edgar W. Dijkstra, which is where the algorithm gets its name from. The purpose of this algorithm is to calculate the shortest path within a set of nodes. Every path has its own numeric rate. For example, the edge rate between node A and node B could be 6, 3, 15, etc. A set of nodes is useful in a graph object, as graphs allow nodes to be connected to each other in a directed or undirected graph. You're probably wondering how Dijkstra's algorithm is related to the real world. A real-world application that uses the Dijkstra algorithm is Google Maps when you want to calculate the shortest route by car between London and Edinburgh. You do this in Google Maps by entering London as the starting point and then Edinburgh as the destination, then hitting the button that calculates the route. Numerous routes will be shown. The route that takes the least amount of time will be highlighted in blue. Visually it looks like this. As you can see, there are 3 routes here. The shortest route has been highlighted in blue and the other routes are in grey because they take longer than the route in blue. So what are the inner workings of this algorithm? I'll explain in the next slide with this simple example. I'll be taking the graph from the introductory slide. Let's calculate the shortest path between A and F. The nodes in this graph are A, B, C, D, E, F, G and H. Each node initially has a value of infinity, except from the source node, which has a value of 0, because that's where we start at. We then look at node A's neighbour nodes. The neighbour nodes are B, E and D. It states in the chart that the edge rate between nodes A and D is 2. D's initial value of infinity is now 2. Likewise, the edge rate of E is now 7, and the edge rate of B is 4. Only node D is visited, as that has the shortest edge rate out of A's neighbour nodes, and we're trying to find the shortest path. Now we're at the D node, we then visit the G node, as that has less edge rate than the H node. When we're at the G node, we'll visit the H node, which has an edge rate of 2. The total rate for going from D to G to H is 3, which is less than going from D to H, which is useful because we didn't have to backtrack. We would have to backtrack if D to H was 2 instead of 4, as 2 is less than 3. If this was the case, we would have visited the nodes D and G, visited D again and then H. Getting back to the point, we're now at location H, and the edge rate of H to F is 1, which has less edge rate than H to E. So we visit F. Overall, to get from A to F, we visit the nodes A, D, G, H and F. The edge rate of the shortest path from A to F is 6. To recap, going from A to D has an edge rate of 2. D to G is 1, G to H is 2, and finally H to F is 1. I'll now implement a simple Dijkstra algorithm in the Python programming language. The reason I'm using Python is that the syntax is minimal, allowing me to illustrate my point better to you, since my code's more readable. I'll now open my IDE and start coding. Thanks for listening to my presentation.